some more requirements on the interpolating functions. So how do we choose them? So again, so otherwise, that's the things we've talked about. So otherwise, the phi-j have to satisfy the following. They must be selected such that when you plug them into the bilinear form, it's defined and non-zero. In other words, they have to have the proper continuity requirement. So if I have if my bilinear form has some term that has partial derivative of u with respect to x, the second partial derivative of u with respect to x, and I choose my approximating function to be x, well, when I take two derivatives of it, that's going to be 0. Right? So it has to be non-zero when you plug it into the bilinear form. They must satisfy the homogeneous form of the specified boundary conditions. So that is, if you're given u at 0 equals to some u naught, phi-j must satisfy u0 equal to 0. Okay. The other thing we've already talked about, right? The set of phi-j must be linear independent. Right? So there we chose phi1 equal to x1 minus x, and phi2 is equal to x squared 1 plus x. Those are clearly linear independent, right? There's nothing I can add to this to get this. Right? But, or I mean, there's no constant. There's no constant I can multiply by that to get that. So in other words, if I would have chosen phi3 to be equal to 2x squared 1 minus x, this would not be allowed, right? This is invalid. the set phi j's must be complete. So in other words, if I have a set x, x squared, x cubed, x fourth, this is complete. In 2D, or if in x and y, if I have x, y, xy, x squared y, xy squared, x squared y squared, this is complete. However, if I have x cubed, x to the fifth, x to the 25th, that's not complete. Likewise, x, x squared, x, y cubed, not complete. So in other words, a complete polynomial is one when you, it actually comes from Pascal's triangle. Does anybody know what Pascal's triangle is? So you have like 1, xy, xy, x squared, y squared, and so on, right? X cubed, x squared, y, y squared, x, y cubed, and so on. So that would be Pascal's triangle. So whenever you use this to construct them, you basically, you'd take like this, or you'd take like this. Yeah, it's complete. You can also, as long as you take a symmetric, you could do like this. If you had some kind of funny 5-noted or 4-noted, yeah. So no, that's not the funny case. Actually, that's the normal quad in 2D. Like quad in 2D, we haven't really talked about nodes and finite elements yet, but a quad in 2D would have 4 nodes, so you need 4 approximation functions. So you'd take 1, xy, xy. All right, so the last thing is that the phi 0 term must be the lowest order function that satisfies the boundary conditions. And here we almost always use polynomials. So whenever someone talks about the standard finite element method, if they don't give you any more information, or in fact, if they just say the finite element method, you're talking about linear approximation functions, or polynomial approximation functions, but usually just linears. So just linear. Interpolants. So